Sharmistha, Vice President of Data and AI Shared Capabilities, American Express, who is also a Google developer expert in the domain of cloud and ML. Sharmistha has more than 19 years of experience in the software industry with a track record of delivering innovative solutions to Fortune 500 companies. She has presented international conference papers and she is an enthusiastic writer in writing new tech trends. She handles the massive amount of mobile crowdsourced data on large-scale distributed systems like AWS. She has proven experience in leading patent portfolio of the company and strategizing future technical roadmaps. Welcome you, Sharmistha. It's a great honor to have you here. NST, you can avoid some things that we don't like. For example, the food that doesn't suit our taste bud or the traffic because of the Metro Chennai work. But we cannot avoid AI these days. And yes, you guessed it right. Here we have AI focus session from Sharmistha to help us see the future of AI with a session on agentic AI and Google's Vertex AI engine. Over to you, Sharmistha.
Thank you everyone, and great to see you all on a Saturday morning, spending time here and getting to learn some of the latest technologies on cloud and AI. So let's keep this session a little bit interactive to get to know what is their expectation, what is the audience flavor of understanding agentic AI and what you want to see. So before going into that further, I would like to thank the CCNF team for inviting me here to in this birthday bash program to share some of the insights on agents and Google Cloud Vertex engine. So what we will learn today. Okay, so today we will cover on introduction to agentic AI capabilities and patterns, agent success metrics and protocols, Google Agent Development Kit, and how we can build agents with Vertex AI Agent Builder. I would also like to show you some of this AI Agent Studio where you can play around building agents, creating images, creating step-by-step sequence of instructions, as well as creating videos. So before wasting further time, let's move on. But I would really like to hear how many of you have used agents, deployed agents? Okay, and how many of you have been using agents on a day-to-day basis to automate tasks? Which platform you are using? Copilot. Microsoft Copilot.
I'm using ADK and
Gemini.
Yeah, Gemini.
Oh, great. So let's move on. So what are agents? So let me not introduce the topic. Let's Bill Gates introduce the topic. Agents are smarter, they are proactive, capable of making decisions and suggestions before you ask for them. They accomplish tasks across applications. They improve over time. As we already seen that you have to have a feedback. They improve over time because they remember your activities and recognize your intent and patterns in your behavior. So there can be multiple types of agents, but we need to be careful where we are using it and how we want their mode of operation, whether we want them fully autonomous or we want supervised and control agents. Control agents are called workflows. So, yeah, so what does a multi-agent framework look like? So let's be less theoretical. I will just cover a gist of the agents and we'll go to the actual examples like how we create and how they operate. So they are specialized, they are scalable, they have to be fault tolerant, otherwise our autonomous tasks will fall in the middle. So they can manage large workloads, complex tasks, and diverse requirements, experts requirements as you configure agents. So some agents will be working for your, as we see, right, they will be configuring some mission critical tasks, some will be conveying the information, and some will be managing the latency and looking forward that continuous real-time feedback, everything is working properly or not. And today, we are expecting billions of agents in next 5 years. There will be an agent marketplace, right? So these agents need to talk to each other. That's why we think of a framework like an agentic mesh, where these agents talk to each other, and you will need to import the agents from what's the true vision looking like today. That's from some marketplace that you import a supply chain agent. You import a specific market specific market or domain agent to work for you, because these are very much specialized and will operate based on how they have been trained. And what is expectation that how we can contribute? You can create your own agents. Not only that, you can use your SLMs, small language models, to create very specific domain specialized agents. So that's where we are leading to an agent marketplace. And whatever we do, we need to be careful that we are not breaking down the things, because they are fully autonomous and we have not tested it and we have not provided enough feedback. So the most important thing is human in the loop. In today's world, a human in the loop is very much necessary to prevent instances of money laundering, or prevent instances of fraud, or to understand how these agents are collaborating, and is there any transparency? What is the data that is flowing into where the agent is operating? If your data is wrong, then the agents won't perform well. And garbage in, garbage out. If you have not given, the agent is expected to operate on a governed data set, it may not operate the way you want. So that's why you need transparency tools, explainability tools to understand the LLM reasoning, how these agents are operating and how they are giving you the decisions. And all said and done, we need different patterns and to see that the agents talk to each other. So before going into that, what responsible AI metrics that we should be careful about when we deploy these Gen AI agents? Data consistency, whether the data is consistent, or the data, what we have trained our small language models, right? Does it at all make sense? Is it biased data? If the data set is biased, your agent output will also be biased. Hallucination, accountability. What is your bias versus variance when you train and the test data set? Your inferencing, what is the cost, time to first token, inter-token latency, and end-to-end latency. And of course, explainability. That is the reasoning of the LLMs. That has to be, the chain of thoughts has to be well sufficiently displayed in a visual kind of a tool that explain you that the agent have operated from A, it is switching to task B, it has again given back the information. That's why we need these MCP servers where we can host those agents who can talk to each other based on specific protocol. So this is a specific, like always there will be trade-off. We should be just aware of what is the trade-off that we are bringing in, whether we are bringing in our own small language models or large language models, and what is we are expecting. We want to work smarter, with great speed or quality, and the consistency should be there across, whether it is we are using SLM or LLMs. So this is for a specific Creo AI, which is another agentic AI framework like Google AI Studio or Vertex AI Engine, or similarly like Microsoft Copilot. So popular agentic frameworks, right? They have to be, we have talked about that, they should communicate with each other, share messages and share information, coordinate their actions on a single task even without conflict. So we will see some agentic AI frameworks where we have to ensure that whether this agent is expected to operate in a sequential or in a parallel or interoperate together. Reason about their environment and why did they have taken the decision, what is the reason behind this that they have taken the decisions. Yeah, so primary components have you seen. Success metrics and protocols, let's go into that. So how this agentic mesh would work, first of all. We have to have a task and we have to give the task, state the task. Example, that I want a set of research to be done by doctors, nurses, and hospital administrators to give me an account of who are the patients who have reported a specific kind of a disease. From the doctor we would get that what the medicine recommendations have been. From the administrator we will get what is the frequency of visits that these patients have been making. From nurses has been how is the patients been, all this specific medical record patients have been recording based on different body parameters. So what we need to define is the task first, planning, then the task breakdown. Who are those agents who is going to execute those tasks? Then agent selection, may have doctor agent, you may have researcher agent, some medical professionals do research, or the RM agent, you need to have a nurse agent, you need to have a administrator agent, and then you start your tool. Tools are nothing but these are kind of an APIs which you can trigger it from your agentic framework. So these tools will be executing. That is, that they will be performing the background action, nothing but it's a kind of an API, they will be calling the LLMs. Using the LLMs, then API call will happen. You need to continuously monitor, learn, and feedback. The feedback, whatever you have learned, that agent should be continuously feeding back to improve the task further. And reflection means, reflection is nothing but explain what it has taken, where it could have gone wrong, how it could have improvised over a period of time. So this is the entire ecosystems looks like, and then let's look into how we will make our large-scale enterprise systems work with an agentic mesh. So what we would definitely tend to look at is the operability, like how robust and stable are they? Are they able to handle the task in a scalable platform? What is, when they are talking to, what is the economic vitality or a mutual benefit of a producer-consumer? They are talking to each other, you have to remember. And then it's kind of an imagine a producer-consumer, that are they able to process the messages, giving the output in the stipulated time, what's the latency, what's the number of tokens that are using. Everything is associated also with your cost. We cannot go on putting things before understanding that whether this kind of a framework or an architecture would actually make sense and is the best state-of-art possibilities that this framework will account for. Then observability, discoverability, that should be able to discover each other. When you actually put an agent into the enterprise architecture framework, you have to register that agent, right? Register this kind of an agent is allowed to perform this kind of task. So once the agent is registered, when it has to perform a task, it has to discover what all information I am dependent on from other agents. There your MCP protocol or the model context protocol, the server will help you, right? Once you are subscribed to a server, subscribed to a framework, subscribe to perform certain tasks. Then interoperability, what's the communication protocol? We'll see some of this communication protocols, and certifiability. So standardization, what's the standardization you are following? Your organization may have some certain standards, your organization may have some certain final layer built on top of MCP, the model context protocol. Are you subscribing or are you maintaining all those standards in place? So that is the. So this is could be that your this is the same thing what we have talked about, but just know that when you deploy those and architect for an enterprise architecture, you should have a registry, you should have task description. Like it's simple, like a few shot learning. You have to explain that you are an agent, you are supposed to do this task, and your output will be in the form of this, and give some examples. Few shot learning if you have done it before, or even you can use one shot learning. Agent marketplace we have talked about, and orchestration. Who is going to call whom? What is the orchestration framework that you are using to have this agentic framework deployed into your enterprise architecture? And sub-agents. Agents can create their own sub-agents, and within hotel you will have hotel restaurant, could be a sub-agent of the hotel network chain. And here you have how do you maintain your memory caching. So usually you will see in very private large enterprises you don't allow caching, but there are long-term and short-term memory. You have to see that how long you want to retain the memory of that agent. If you are sometimes answering to customers, right? So the customers say, imagine a chatbot, you are replying. So customer is asking, so are you going to retain that information to the long-term memory based on the session? But if the customer has deviated and started asking you wrong things, which is the bot is not expected to perform, do you want to retain that kind of a conversation? You don't want to. Suppose you are going to a airline booker, booking assistant, and you are asking, can you deliver me pizza? It's not needed to remember those wrong questions. So that's the part of the memory that will play an important role. Yeah, so this is like different types of kinds of agents can work though. It could be sequential, parallel, in a mesh, or it could be like they are converging together at a certain point of time, operating in a sequential structure, and then they take a consolidated decision that they have operated separately. Now they come together and do a voting kind of an assembly, like what would be our next course of action based on our past performances. Yeah, so another part could be like cooperative and competitive multi-agent systems. So cooperative systems will always give information, like we have do in a team kind of a setting. We help each other and try to find a team shared goals, while competitive will be like a gaming system. I'm doing some kind of random gamification, like somebody is boosting that in a bid system, right? So who is actually, what is the best outcome that is possible, kind of a reinforcement kind of a learning, even if you can think of that, the gamification of the system and competing it to get the best outcome. So it's up to you how you want to configure your systems. So you can see that you can also establish a kind of control in your systems agent, where you give more workflow control or less workflow control, and where you define the task more rigidly than you keep a less defined task. So based on that, it is a loosely coupled or a tightly coupled system, and it can be more adaptive, or it can be like a, if you have used LangGraph, you will see LangGraph operates in two modes. One is the fully autonomous mode, where you have the agents operating out of the work fully autonomous. Another one is you can use LangGraph only for orchestration purpose, where you define that instead of writing if else, you define this is going to be your workflow, and agents can subscribe to that specific workflow. If this condition happens, it will go through this workflow. If doesn't, then it will go. So it's more of a structured definition, roles defined that you can use. And all these agentic frameworks, if you see Crew AI, Copilot, or whatever, the Gemini, and others, ADK, like others, you will see that you have those flexibility. You need to see that how you want to operate, and based on that, you select your mode of operation, your coupling, and your flexibility. Yeah, so this is just an example that how they are operating three specific agents. One is going for the vector DB, storing the documents, vector DB search, and once the query comes, another agent comes in, it searches the APIs, and one has, like, it consolidates the result, search result, and brings in advanced cognitive skills. So they are just dependent, one has to finish, another has to do, because if you look for a normal grounded search, that's how it works, that you have to ground information. Say a RAG-based retrieval. You have to get the query, formulate the query, add additional context, storing the data, vector DB, and then while formulating the response, you have to give the response back, and then finally rank the results and give the best answer possible to the customer or the end user. So this is just a specific example of it. So let's go through this Google development agent tool development, what they offer. So modern agent tasks will get more and more complex. Today is still simple, because we need at organizations more guardrails to be established, and I'm sure that if you look at fintech, there will be definitely, they won't go fully autonomous in day one. So how we can handle those challenges, that multi-step task, using tools, reflection, and adaptation, and how we evaluate those metrics. And in adequacy of traditional metrics, we cannot use those traditional deep learning, even deep learning metrics like precision, recall, and saying that accuracy, it's just not, it doesn't define accuracy. What do you mean by accuracy? What is your goal? More specific to goals, hallucination, relevancy. These are the different types of GenAI metrics that will evolve in defining agent success criteria. So this simple, you can even bring in LLMs to do an LLM-based reasoning, what these agents are doing, and specify metrics that you want to do, rule-based evaluation, human evaluation, or as we talked about, the LLMs gives reasoning and evaluates how the agents are performing. So it's up to you which one you want to pull in. You can add in more LLMs. I would say that will give more insight to the performance of the agents. So few agents communication protocol. There's the model context protocol. You see this has a central server, right? A kind of supervisory server which invokes other small sub-agents, and that can specific to different domains. So you can talk about supply chain, you can talk about retail, you can talk about banking, and then finally the consultative decision, getting the information from in out, who invokes whom, that's chain of thought. Finally the chain of thought concentrates down to a final decision. Easy to manage but limited cross-agent collaboration. So another is the agent communication protocol. So you have a call to this. Finally, you have a network of agents in a microservice environment, and get request response, comes and collaborate. And of course, you have to have a structured information or kind of a workflow with external systems, because you are invoking external APIs, and come down to a consolidated output. What's the end goal of this agentic communication protocol? So it may have strict message schema or orchestration rules. So agent to agent, so agents talking to each other. So hotel agents, this specific example is like the travel industry, right? So hotel, when you book the flights may have some tie-ups with any hotels. Hotels may have tie-ups with your cabs. Cabs may have tie-up with the local sightseeing sites or local shopping malls. Like sometimes they take us to the specific where you have to shop. So this is how the agents communicate with each other. And what we would look at definitely to account for the overall success of the agent, the system level efficiency, the session level, and the node level efficiency, right? And we have to, everything has to be accounted in terms of number of tokens, and finally, because that accounts to your cost. So be aware, like for session level and system level efficiency you are gaining, and constantly monitor that how agents are performing and the agent's trajectory, if they are diverting from what has been established as their goals. So these are, again, we have talked high level discuss intent. Intent means what the agent is supposed to do. I won't say goal, but intent may be, the agent may be intended to look for products which are of a specific brand, a product category. That is the intent of that agent. Then user's intent. User what the means, the agent comes understanding the user's intent, of course. Then the accuracy, response relevance, the how the agent is not diverting, there is not diversion in the system and is able to accomplish the task properly. The response time, and of course the model accuracy. So model latency. So how much time it takes to go back and forth executing your APIs and nothing but executing the APIs in the backend. So, and also you have to see the retrieval latency, the error rate, stability, user satisfaction score. So there could be some problems when you are not providing additional contextual information when the agent is, when you invoke the agent, right? Before that you have to ground it with additional information. If there is missing information, you are not able to provide additional information. It is now, see, everything is becoming very much drag and drop, all tools are there. Now it is a developer task to see, are you able to ground that information properly? What additional contextual information you can bring it from your ecosystem of enterprise architecture that the agent will be grounded before executing the task. Otherwise, this will lead to mislead the agent and they won't be able to understand the instruction or execute the task properly. So it is also, we also have to play a critical role when we create those agents as agentic AI developers or architects, that we are giving additional contextual information to make the agents understand what it is intended to do. Yeah, so if you move on to a Google Agent Development Kit, so it is very much available in GCP architecture and all the AI engine architecture. We have talked about like adaptive task management and orchestration, because that will be, you are defining the network, how, you have seen the network, right? You have to define the network and how adaptive they are what is the role, and even if you can go at the lower level, if you are executing LLMs calls, you can define the temperature, what you are expecting to generate for the agents. And you can have different models, who can do the planning, who can do the reflection tools, calling external APIs, and self-learning. And then the data storage, where you will have the vector DB and other storage, knowledge graphs even you can build in to have additional contextual information. So tailor Treza's knowledge update output, what you are expecting, and the service layer, right? Whom you are servicing, are you going to give it to some personalized recommendation engine to the end user? Or are you looking for something like kind of, say, some information, just giving the user some information based on condensing information from different sources. So that is a user level API where final output is generated and given back to the user. So the abstraction will be like first the orchestration framework, the agent framework, what you are using, agent development kit, Google's, Microsoft's, what toolkit you are using. Define the land graph. The land graph is one of the popular orchestration tools. You can see the code here. Like you are defining the agent, you are defining the workflow, which could be a state graph, and then lower level you are using LangChain, use SafeChain, because these are more prone to injection, prompt injection attacks. These are more safer for prompt injection attacks. Define your prompt, and then you execute it. Actually call the tool or call the actually let the agent perform the task. So that's happening at the last. And this is how when you plug in an enterprise framework, right? So you have your agent do all this agent engine. If you see, we have talked about everything: monitor, log, trace, session, long-term, short-term memory, long-term memory bank, how much you want to retain the information that the agent has done to a session interaction. Then you have code execution, identity management, and all these are supported by the Google's agent guarded, model guarded, what they call it at. And there, underneath that, you have the control and ability to have the tools, describe the tools. Tools could be little small functions with decorators that defines that which external APIs you are calling. Nothing, I will see one example as the orchestration framework. So, and you define what kind of agents they are, and are you enhancing your agentic framework? Are you using knowledge graphs? So if you have followed a Neo4j, you will see that LLM performs better, or your agents will perform better when you have knowledge graphs, because they help to build the semantic relationships across a product or across a chain of relationships. So if you are trying to use knowledge graphs, it will boost your performance. So you should try out using knowledge graphs as well. So I'll go through this fast. Let's see some examples. So we have model, because that's the basis of LLMs or agents. You use Hugging Face models, or you use GPT 4.5, 5.01 is coming up, Gemini, any model tools which actually fetches the data, and orchestration, defining that how they interact and execute the runtime. So this loops like end-to-end, like query, response, and we have talked about grounding. It's our task to do the grounding. Don't expect that the framework itself is doing everything for us. They will also do the grounding. We should be careful to have the grounding, to ground the user request to give the proper response. Yeah, so what we have discussed, if you look at it, that Google's agent-to-agent communication protocol in a multi-agentic system, that how it looks like, because at the end of the day, we are going to the MCP server, because it has a structure schema definition for communication, and you have this the agent network communicating in that to that server, and you will host your cache, database, whatever you want, backend system to be backed by more contextual data. And this is the breakdown. What you have here in the Google Vertex AI engine, agent engine. You have agent frameworks. We have talked about similar to LangGraph. You go Llama Index. You can use LangChain. You can use other vendor platforms also. Creo AI, other Python frameworks. Tools, MCP tools. You can use your custom built tools. And models is the Gemini model guarded and fine tune models. You can even do your model fine tuning here. Model fountain is nothing but you go to the Vertex AI, just take a model and give say another CSV or another PDF and ask it to fine tune and set the temperature. So this will be as easy as that. And observability and evaluation. So there are different vendor platforms you will see, like Google, they will allow you, let's say some custom platforms like a Salesforce say, or ServiceNow, they will give their custom models. So you can bring your own agents, what you have created, into your business use case, and based on that business use case, you take it to the TAG platform. So these are the 4 steps: develop, deploy, query, and manage. This you have to constantly maintain to have a constant, robust agent framework system. So which will help you to do a predictable, reliable, and structured framework, and constantly help you to compose or develop, discover new agents that may be useful based on our monitoring logs and traces. So this is our engineer's task. I want to reiterate again, grounding the agents, that's the most critical part of it, and that's why we need so many data sources. Multiple data sources which you can put it in BigQuery, multiple databases, join the SQL and ground the agent properly to help the agent respond all the steps which we have talked about: reasoning, planning, retrieval, review, generate, synthesize or summarize the information, categorize my information in terms of this is the doctor treats so many patients, but categorize what kinds of patients are coming in based on the season or the type of hospital or nursing home it is. So indexing, you have to index, retrieve. Indexing has like vector database, to retrieve the vector database, convert that query into a vector, store it into the database, retrieve, ranked result retrieves, and generate. That is a summarization. And this is your grounding service. Gemini provides your grounding service API, you can use that. The middle part is most important. If you want your agents to perform more and more well, add fresh data to it, give some incentive, some boost to it, some nutrition with the fresh data so that it has additional grounding context. This is the same thing. And this is how you connect, right? You have BigQuery, you have your Google data storage, kind of an S3 layer and embedding, and then you retrieve it, refresh the query, give more augmentation. Augmentation is nothing but more contextual data, search, rank, and generate. Generation, whatever model you want to. Need not be you have to use Google Gemini, but definitely Google's platform, it would be great to use Gemini. But you can also host your own LLMs as well. So there are some simple code. I want to just go through going through some examples. So import the grounding tools, and then state the LangGraph agent. So that is going to do beneath it is using LangChain, and this is your agent actually. That respond agent query. That is your tools, right? So the tools is the grounded search tool. That makes the actual query, and then you get the response, the agentic response. Similarly here also, you register the grounded agent and say it is a movie search tool, grounded search tool. These are your tools, which is nothing but API calls using LLMs, and you get the response. So in the query you can write whatever the prompt. In the query you are writing your prompt. You want this information to be correlated with some other information, add another information to that. That is you as a user, you have to give the prompt. So this is another example that you have to definitely use the language, the model name. So here we have used Gemini Flash, and then you can describe, and when you create that agent-to-agent communication, you have to mention a large number of sub-agents also, because you are creating a mesh where agents are communicating with each other. And then you create the pipeline. Right inside you can create the sequential agent pipeline. The step 1, step 2. Step 1 is nothing but one kind of step 1 fetch, and then is process. You get the information using the tool, you process the information using the tool. And each where you have to give your prompt, how you want to process the information. So similar thing, not going, just do some some demos what Google's AI Studio can do us. So just food for thought, conclusion, always design the right feedback loop so that the agent is able to sensitize your environment, sense the environment, analyze the data and take the right decisions and actions. And not only this, they are supervised or autonomous, it's up to you how you want to make the execution and perception and decision making. So even you can add your own processing logic so that it is much more controlled in your hands and it doesn't break. As we evolve, means as an industry, we are evolving towards autonomous systems. So be careful while designing fully autonomous system unless we are 100% sure. So simple reflex, model-based reflex, goal-based agents, and have this opaqueness that due to limited visibility how we are operating, right? How we can bring in more transparency tools that can give us that with this data is not proper, this there is some leakage in the data or the models that may leak some confidential information. So this add all those transparency tools in your place so that when you are operating in enterprise there is no data leakage or nothing wrong happens. Yeah, so you have the flexibility, you can mix and match. Need not be agents are very much bring your own agents. So any framework you can create agent, another framework can bring that agent into your framework or the tool you are working on. Yeah, so AI agents, very important, will become our digital assistant, helping us to navigate the complexities of the modern world. They will make our lives easier and more efficient, as told by Jeff Bezos, founder and CEO of Amazon. So let's see one or two examples. You can ask questions also. So we can have you used a Google AI Studio? So this is nothing but they are talking to each other and getting what sequence of steps you want. Say I can show you this one. So anybody who has done civil engineering here? So we can write some prompts, and this background, an agent is working to give you the sequence of steps. So this is what we are called about planning. Like what's the step of instructions that you want that agent to come back with as response. So if I want to give a 3D offer, say high-rising building, to do structural planning and show it by step how to plan, say the design and floor plan with images. So you see it is getting generated, which you would have done in AutoCAD previously. This is how it is coming. What you have done with AutoCAD manually, it is coming up. Everything is given and the expression is also given. So let me ask more questions to it. I don't know how it will look. Any questions you have? How do you think this building is resistant to, say, earthquakes? Let's see. So this is based on what they had given as plan. You are asking further queries to understand that what's the design have been proposed and how it is going to act based on your specific criteria. This is one example. Another example could be create 3 agents, say. And finalize the booking. So 3 agents, say 3 to 4 agents are talking to each other. Say flight, hotel, cab, when a user goes and asks for it, and it will help you to finalize the booking. So how this agentic communication will appear, it will show you. It will analyze the agents, it will give the task and craft the sequence of information who are talking to each other, and it will give the response of the dialogue flow. So trip coordinator, data, cruncher and the bot. So please feel free to play with this before you are actually using the APIs. So you see that I have asked for 3 agents. It is the trip coordinator, data cruncher and the booking bot. Data cruncher is an analytics agent which will look into the market and see that how the weather it is, how the crowd density, traffic patterns. So trip coordinator starts the conversation and then it goes to the data cruncher, and trip coordinator and data cruncher converses among themselves to find the trend of the visiting places what the user asked for, and then gives it back to the end user. Say option A, option B, option C, which you want to take. And then the booking bot will confirm the booking. So this is how a specific agentic interaction will work. You can play with this, and whatever prompt you are thinking of designing to the APIs, play with this, see that whether you are wanting this kind of an agentic communication before you actually go and do your APIs and tool calling. This will be a ground for you to play. So this is one thing I also wanted to show you. Yeah, so inside Google Console Engine also, you will have all the information. I don't know whether you have used it. Any specific service you want to know about Google Cloud, there is an LLM running here on the background. You can ask any Google services, it will give you summarized information. So if you have not used, use just Google. You don't have to pay anything for using these services. These services are absolutely free for you to try on, and then you go and use the Google Vertex engine. So one I have showed what is a secret manager. Then another question I have raised, how to create agents. It gives you detailed description how to create agents. So you can follow this step by step and create your own agent into the Vertex AI engine. Here I have created say 2 small boys. Say I add 2 small girls playing in a swimming pool. So I exhausted my quota. So I try, I have exhausted my quota. So my quota got exhausted. So here you use small prompts, say very simple prompt.
You can see this.
And generate your videos. The quota has exhausted. So try that. Create different accounts. You want to switch to other account, and you can create
History maybe. We can see the history.
Yeah, this was my history. I created boys playing in a swimming pool, and this was the video. Yeah. Hope you have used LLM notebooks. If you have not, try it out. So you import all the documents, find out from your Google, if you have a Google storage, what is called Google Drive, put the documents, give the link, or you can even add sources. Here you can upload your sources, you use Google Docs, link, website, whatever you want to. Import those documents, start researching on those. So what is GDPR? Import all the documents, what is GDPR? From the sources, and start playing with this. If anybody is doing research, it will be highly helpful. Anybody use this LLM notebooks? Okay, I think I have covered everything. If you have any questions, yeah.